Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about conditional jumps. So previous class we discussed about unconditional. So unconditional, no condition will be checked. Here we have a conditional jump. So we need to check the condition. So based on that condition is true or false, that branch will be taken or the next instruction will be executed. Look at this example. So this instruction causes jump occurs only if the condition is satisfied. That is if the condition is true. Otherwise the program continues to the next instructions. So normally we have a set of instructions. So if we have a conditional jumps, so if the condition is satisfied, it take the branches. If the condition is not satisfied, next instruction will be execute. Look at this example. We have the label loop move a comma p1. So the port 1 data will be moved to accumulator. Next, jump on 0 loop. That means we are going to check here as a condition jump on 0 or jump if 0. So here if accumulator is 0, it again go to loop. So loop is a label. So look at this label here we have mentioned. That means if it is a 0, that is an accumulator data is 0, it will be jumped to loop. So that means these two instructions will be repeated till this accumulator data is 0. So how the accumulator is 0? It will be read from a port 1. So port 1 we have an input port. So we have some switches or a sensor, something. So whenever the data is 0, it will be repeated throughoutly reading the data. So once if it is a non-zero, then it will be comes out from the loop. Because here we have an infinity loop till it non becomes a 0. So it checks this whether A is 0 or not. If it is A is 0, it again repeats these two instructions. So what two instructions? Just read the data, again check whether it is a 0. So if it is a 0, again it reads the data, again check it is a 0. So these two instructions will be continuously repeated till this port 1 becomes a non-zero value. So once if the port 1 is non-zero, so the accumulator becomes non-zero value. So this condition not satisfied. So once if the condition is not satisfied, this branching will not die. So this is the conditional jump now. So this condition is not satisfied. So it will be terminates, it go for a next instruction. So move B comma A. So the A data will be moved to B. So only in case the port 1 have a non-zero value, so the data will be moved to B. Still that it have this within this loop only, it will be executed. So here we use this accumulator content for a zero value checking. Look at this different conditional jumps. This is JZ, that is jump on 0 or jump if A is 0. So here we use this relative addressing. So we already discussed this relative addressing. So it is similar to S jump. So plus or minus 128 locations. So we use jump if A equal to 0 or jump on 0 or jump if accumulator content will be equal to 0. So jump if A equal to 0. Same thing we can use jump on no 0. So here the jumping will be happens if the 0 flag sets. The data is 0. Here jump on no 0, that means if the content is non-zero, it takes the jumping operations. So jump on no 0 relative addressing. So if the accumulator content is not 0, it takes the branching operations. Next will be JC jump if carry equal to 1. That is jump carry flag. So jump on carry, it go for that relative address. So if satisfies, that means if it have a carry flag, it jumps to that particular location. If no carry, it will be next instruction will be executed. Same thing the opposite component jump on no carry. Jump on no carry means if there is a no carry, it takes the jump operation. If there is a carry, jump operation will be skipped. Look at this. Next will be JB. This is here. Look at this JB bit. That is a jump on bit. We need to mention any bit address locations. So we have so many bit addressable registers and bit addressable locations. So we can use any bit address. So that bit address content will be checked whether this bit, that is bit address content is 1 or not. Jump on bit means if that particular location content is 1, it will be take a branch. If that particular location content is not that is a 0, it won't take a branchings. So jump if bit equal to 1. Look at this jump not bit equal to that is 1. That means bit equal to 0. Look at this complement of this JB jump, if not bit equal to 1. So it also uses the any bit address and the relative address. If that particular bit address content is 0, it takes the branches. That is a non bit. That means bit is not equal to 1. Look at this next one, JBC. So here we use clear also. So for example, some cases only one time it need to take a branches. That's here they use this JBC jump if bit equal to 1. Also it clears the bit. So again if you come and check it, the bit is already cleared. So that means only one time it should be executed. So that's why we use this JBC. So jump bit clear. So bit that address and then relative address for that. Again, compare jump not equal a comma direct address, direct value and then relative address. So that particular direct address content will be compared with accumulator, and then if it is, see look at this CJNA jump, that is a compare jump not equal. So this A and this location content is not equal, it will be go for a branching. That is a jump. Thank you.